Welcome to the Tech Insider podcast. I'm your host, Nick Hume, founder of Hume Consulting, specializing in technology strategy and transformation, sustainable digital infrastructure, and diligence for capital market investments. Tech Insider discusses leadership, strategy, and technology trends with industry-leading executives around the world. In this episode, I sit down with Tobias Hooton, founder of Stellia, an exciting startup disrupting data flow and GPU connectivity outside the data center. We discuss the future of GPU clusters and the immense challenges the HPC world presents. Our discussion also covers the complexities of data sovereignty, the rise of enterprise AI adoption, and discuss Stellia's innovation in network infrastructure, enabling GPUs that are kilometers apart to function as if they're right next to each other in the same rack. Coming to you live from YOTA 2024 in Las Vegas, tune in for a deep dive into how Stellia is connecting the AI-driven future of computing. So Tobias Hooton, thanks for joining us on the Tech Insider podcast today. We caught up a little bit last month there in September over here in the US. You're based in the UK. Tell us about yourself and what you're up to with Stellia.
Cool. Background about me then. Early career started off in counter-terrorism and counter-defense, the British government. Spent quite some time building security platforms and security teams around networking and security. Left that in the early 2000s. Since then, built 4 tech companies, left 4 so far, all in networking, security, infrastructure. We ran a 250,000 person public hosting company, ran a big network engineering business, ran a connectivity platform. And a lot of that early learning in DNA is kind of what started Stellia. So Stellia originally was born from a research and development thesis that basically said, we believe the internet's dead. This aging 40-year-old platform that's trying to stitch resources together is unlikely to be the thing that continues for the next 30, 40 years. At the same time as we were investigating that alongside some of Meta's deep tech team and some of the guys at some of the big CDNs, AI was really coming into power. And it quite quickly transpired that actually what we were getting involved with was building the underlying connectivity protocols from the ground up to connect this new asset class together. So today, that's where Stellia is. We are effectively building and now delivering the underlying backbone, connecting GPU clusters together all over the world.
Awesome. Very cool. So let's dive into that just for a sec. So Stellia is, you've got these large GPU clusters all around the world. This digital infrastructure, some of us know about, the GPUs, the NVLink, NVSwitch, all that's at the rack level, right? So you've got all these interconnected and InfiniBand kind of doing it at a network level. So then where does Stellia fit into that puzzle? So how do you interconnect them? And is that what Stellia does? Or am I off there?
No, you're absolutely bang on. So we have a hardware stack and a software stack. We're pretty much a software business that runs on our own hardware stack currently, but watch this space because that's next year's announcement. So currently we have a transport platform that resides on the border of these clusters, which is physically interconnected into them. And these clusters are being deployed either in Stellia-enabled data centers, or Stellia is being wheeled in by some of the major vendors, the data center themselves, or the model builders. And that technology platform interconnects into the heart, either spine or leaves inside those clusters, depending on how they're being built and designed. And then that transport protocol integrates into that network backbone to bring awareness of resource connected. Then on top of that resource platform, we have sets of protocols that achieve different things. So you have a protocol that the augmented reality and the VFX companies are using for shaping workloads across different GPU clusters. We have protocols that the GPU providers themselves are using to get to an accelerated and conditioned internet. We've got accelerated protocols that allow people to either interconnect GPU resource together or do things like edge inference distribution. But all of that is enabled outside of the data center. And whilst most of the major vendors are focused on within the 4 walls, we are firmly focused on outside of them. We kind of think about ourselves a little bit as a hyperscaler without the compute.
Very cool. And so I'm curious how that, so I spent a lot of time in the OCP community and they are doing a lot of disaggregation of systems and services. And so you look at the infrastructure today and it's tin in a rack, and the racks with more tin, and they're all interconnected by high speed bandwidth and low latency, and that's never been more important, is getting the compute really close to each other, whether it's the GPU and the memory, or it's the GPUs and the other GPUs and the racks, they're just stuffed in, and density is getting challenging because the heat produced and things like that. So getting those longer, distant and higher latency workloads, connected is obviously before we talked about this, I thought impossible, right? So because everyone's sort of pulling in, and you're saying actually we can live in this world, which is a longer latency but more stable. Is that right? So it's sort of if I have guaranteed, let's not call it bad latency, but longer latency, like in the double digit millisecond versus sub 1, then you can actually have these things talk to each other, and they essentially operate as if they're next to each other anyway. Is that how it's working?
That's correct. There's a few approaches to this currently. There's one approach from people like the Google DeepMind team who are thinking about actually open sampling, the open DI low code into GPU connection framework, which has now been published. Their approach to it is still need low latency, but we're going to reduce the overall bandwidth demand by using data sampling instead. There is a reconciliation activity happening behind that to counter that effective minimal caching effort there. What we found when we looked at the reference architectures from different vendors at actually why things were so sub 1 millisecond, for example. Well, sub 1 millisecond is actually quite a wide boundary. And when you look at where will it actually break, the initial work that we did was to push that latency and see, okay, is it 0.1, 0.2, 0.15? Where will it actually break specifically? And then once you understand that, we understand how to time the network and create more stable platforms. In our early research, what we actually found is that stability is way more important than low latency. And low latency has to be a given. So there has to be a latency boundary, a bubble. But actually inside that, what's more important is stability. And we can see that now in compute clusters that are being deployed. If you take two identical clusters deployed by the same provider in two different buildings with things like different environmental thresholds and different cable lengths, those two clusters will perform differently. And this is a problem that's facing model builders currently. Just because you're going to go and buy 1,000 cards in one place and 1,000 cards in the other doesn't necessarily mean your compute output's going to be the same. And the bigger challenge that we've got actually when joining these clusters together is not in the transport technology, it's in the difference in compute resolution at both ends. And that when you're trying to connect a resource together, it kind of needs to be of the same plane currently to make them talk correctly. And if you've got different performance characteristics, that's what's breaking the job.
Yeah, right. So that's really interesting. So are you agnostic then to, I guess, both the GPU vendor or the compute vendor? You're agnostic to the location to some degree. Are there out of bounds for where this, like, is it Australia through London? Let's use those examples. Is that too far? Like, what's too far? Is there too far? And how does the system kind of get around some of those limitations and bridge that gap?
So there are defined limitations that we're working through currently. So at the minute we can do GPU to GPU workloads inside what we define as a metro zone for us. And that's a couple of 100K. But that's far enough out for us to be able to get a good density of data centers and regionality of providers. We can sort of disaggregate that pool of just one GPU as a service provider across multiple providers within, say, a 200-kilometer radius. That can be done. We're working on the technology currently to throw that further. We're working with some of the biggest vendors in the networking space to try and attack that. What's also quite interesting is that there's a bit of a rebirth of innovation, some of the long-haul transport market technologies. It's been rather stagnant for a while. 400 gig kind of came, and then 800 gig is kind of here. We've had 1.6T on trial since February this year, and we are now working on standards even faster than that as well. But there now seems to be an awakening in the long-haul market, so that actually will be required. The problem with that is going to be cost, and most of the existing telcos are shackled by debt, and a customer base that isn't going to pay the sorts of money needed to foot that asset. So you have to think of new ways. When you look to how hyperscalers solve this problem, if you remove the money a second, they're technology-driven, not platform-driven. So they'll look at it as a hyperscale challenge will be, I need to make these two things talk, then how do I do it? The rest of the market tends to look at the product and what capabilities it's got and then try and slot that into the business challenge. So if you're going to try and solve these challenges of not only connecting GPUs together, but doing things like connecting remote storage clusters into remote GPU clusters, avoiding the need to put a very large, vast or Weka cluster in the same building as your GPUs, and actually distribute and disaggregate more, they are other challenges that we are solving as well, and they're slightly easier to solve. But the GPU to GPU piece right now for us is limited to a metro, and we're rapidly working on growing that out at the minute with all the vendors. We are agnostic to all the vendors.
Yeah. So it sounds like, I mean, you were, during the introduction, you talked about the different businesses that you've worked in and around and founded and exited, et cetera, one of which was a networking company. Obviously, that experience and that knowledge is sprinkled throughout those solutions you're referring to. You talked about Stellia deploys hardware into the environment. You talked about there's a stack, there's a software stack obviously as well. And you talked about, there being some hardware being developed. Is it too early to sort of talk about what that would look like? Is that switching? Is that server and, bespoke hardware? Is it, metro routers? Is it software that runs on top of those things? Like what, at a high level, without giving away too much for next year's announcement, what does that look like?
Yes, we've got a high density software stack right now, which is 196 by 800 gig ports, which is our border as we start there. We have an operating system that runs on that built by us, and we have an orchestration platform that sits on that built by us as well. So we don't think about routers and switches as such. We think about the service of packet transport or the service of interlink, and then we look at that as a software application rather than an asset. Right now, we are deploying our operating system and orchestration platform onto our own hardware, which is Broadcom backed. It's no secret. And it's bought off the same production line as the hyperscalers are buying from. It's white box. We are rapidly working with at least 2 other major networking vendors currently to have that transport platform and orchestration platform integrate with their tin. There's a few compelling reasons for that, but first and foremost, nobody likes a vendor lock. When we firmly believe that people should have choice. You see that inside the NVIDIA ecosystem already, where people are not following the reference architecture verbatim, and they're making certain assumptions, and it's still working fine. And also, we can accelerate development by getting contribution from different people in different environments as well. It's actually quite interesting looking at the performance deltas between these compute environments when they're not using the reference architecture hardware. So at the minute, our software sits on our own asset, but it won't do by the early part of next year. The other journey we have here is with Bluefield, with NVIDIA. So integrating ourselves down into Docker onto Bluefield. There's a few reasons for that, but bypassing the kernel being one of the major ones. It's much faster to do it with the DPU. And then we can do code transport from NIC to NIC between servers on a global basis. There are other interesting business requirements coming up that we're seeing. We're definitely seeing a transformation in the enterprise space. We're definitely seeing logistics, healthcare, deep tech, biomedical science companies grappling with this resource right now. And they come to the market with a different requirement. Model builders will come in and say, no, I want 1,000 cards for 262 days, please. The enterprises will come through with a business requirement, and they don't really care as such which cards they're running on to achieve that. They look at the timescale and can it be done? And that opens up an opportunity to actually stitch together some of this sort of stranded resource piece coming up into a compute cluster that's fit for enterprise. So if we can provide that capability back to them, we're just the glue. But that is a second life use case piece.
For sure, yeah. I think we might have talked about this when we met, but the partnerships with some of those marketplace vendors and brokers that would you jump onto Vast or HydraHost and those, and you're looking for a couple of GPUs or a couple of hundred GPUs depending on what you're looking for, because that latent stranded capacity is just sitting out there waiting for a customer, or it finished early, or it's available for whatever reason. And, that can be a desktop GPU, or it could be, an SXM5 1,000 node cluster, sitting off in West Texas somewhere. So you've really got a couple of good areas to partner with folks to really embed the software stack and get the thing out there, because you could do it from a networking point of view, like you sort of discussed. And I think you've got depth there. the marketplace offering as well, and stitching together those pieces. And then just, even from the OEMs, right? So that could actually be, an interesting piece for them to sort of add as an option, as something you can, extend into theirs. I was talking to the Weka guys, about using those DPUs as well. And so they're a marvel of, innovation to sort of offload a whole bunch of stuff and accelerate workloads, whether it be, transport and storage or encryption or whatever it happens to be. It's like everyone's coming for the CPU. The CPU is like, just been sitting on its hands for some time. And there you go, GPUs, DPUs,
TPU,
XPUs, you want to call them, NPUs. And so it's kind of interesting to see how that's changed over the years. And so, where you've come, the companies you've worked in and around the IT industry, the internet, kind of industry as well, how are you seeing the differences between then, which was not long ago, maybe 5-10 years ago, and now? So, before it was kind of centralized and controlled. Now we're seeing this explosion of innovation and disaggregation of services, and it's a lot of startups like Stellia and disrupting different industries at the same time. So what are your thoughts on how that changes over time from where it was, where we are now, and then into the future?
This is really interesting. So there is definitely a huge divide in the community now bigger than I've seen before. So if you have come from a telco engineering background, this whole world is completely foreign to you. And we see that even in recruiting people, right? If you find the best network engineers that are CCIE or JNCIE qualified guys, and they come in and they approach the design challenge very much from a telco design principles mindset. But over the last 3-4 years, this is all net new landscape. So there's actually a relatively small pool of people in the networking community that have the depth of expertise outside of the hyperscalers to properly be able to pull these challenges apart. So we're very lucky in our team. We've got that expertise from people that are able to apply deep experience and understand new technologies as well and sort of meld the two. We talk about this a lot with people. It's a complete rip the rule book up and start again. There's very little that actually is equatable between the two. Of course, inside these clusters, there's Ethernet management networks and all the rest of it. And there's routing, and you have to have an understanding of how nuts and bolts go together. But actually, the way in which the transport layer is being augmented now by these vendors is changing, and changing rapidly. And we are lucky enough to know a little bit about what's coming out next year from some of the biggest vendors, and we're sort of part of some of their dev conversations. And we are going to further exacerbate this problem unless we can think about how we're going to actually move traffic, not only this volume, but different types of traffic that didn't exist before. So one of the code-based experiments we were doing was pushing traffic into the forwarding plane of an MPLS router and seeing what happened. And it just drops the traffic. It doesn't understand how to forward. I mean, it provides best efforts forwarding, of course it would do. But ultimately, it drops the traffic. And that, when you have less than 1% packet loss in most networks, you wouldn't realize. But in these networks, you absolutely do. So all of your principles about how you design something have to change, and it's actually quite challenging to bring people on that journey. You have to really forget everything you knew before, hold on to the principles, but forget the design, forget topologies, and start again.
Yeah. No, it's an interesting concept, because I think so I'm not a network engineer, full transparency. And though I worked at Amazon and was lucky enough to manage a large team of network engineers and folks out of Sydney, out of Seattle, and manage the global team there eventually. But what's interesting was when we hired those folks and we needed to build a new team in Sydney, seeding off an engineering team for the first time down there to connect with Seattle and Dublin. And we were hiring network engineers, to your point, that were triple CCIE, qualified. And we had them coming in, deploying, difficult but not relevant, devices and infrastructure into the world's largest network, right? And in a live environment. And the scale was just, trickle, woof, up and to the right. Now, the challenge we had with that was that, those guys and gals were from service providers, from, large scale, internet providers, et cetera. And so we had to retrain them at the time. And they were network engineers used to hand jamming out and command line. and we had to change their entire focus to be automation engineers and development engineers. And so, basically pairing them with a software engineer and saying, hey, this is Amazon's, core stack of libraries, et cetera. Use those and, do more with less. You don't want an expensive, essentially smart network engineer fat fingering commands in and making a mistake where you not only can you not afford that mistake, you have 85 of the things you're deploying one a week of. Now that's the standard per week. Yeah. So we had 100x growth, over a period of time. And so that it came from a necessity of both scale, and I guess the necessity was that it was, what you've done before is completely different to what you're doing now. And I guess to your point, looking at the border and the interconnect at a WAN level, let's say, it's changing that, whether it's the protocol, the concepts inside of that protocol, and the configuration to ensure that those things are going to work, in a different way, but still meet the needs of the demand, which is, I want to connect these two things which shouldn't technically be designed to connect together.
That's right. I mean, we found ourselves starting to develop entirely new protocols for things that are not directly part of the product. But, we've got a protocol development underway for a new link layer discovery type protocol, because we've just found there's inefficiencies in what's currently available in some spaces. I mean, that sounds crazy, but it's actually not that difficult to go and build something like a link layer discovery protocol from the ground up again, if you have the libraries of what you're going to be connecting to as a relatively defined set. But we've just found that we can actually make, when you look at the process of networking as opposed to the functions and protocols available to you, what are you trying to achieve as an outcome? It gets much easier to try and solve the design challenge. But I mean, we've done that. We've done this for 4 years now, and we start looking through, how do you make something more efficient? How do you not just engineer a better network, but how do you actually start to define new principles and standards for interoperability between people? Because the next thing is going to be that. I mean, the biggest problem we're facing right now is the non-standardization of compute resource. If you're going to start to have enterprise, which is the next $1 trillion market, adopt AI or accelerated compute on a global basis, the interoperability, the open standards piece, that becomes something that's going to be put under more and more pressure. So that's something that we're focusing on.
So, yeah, no, that's fascinating. I think I know you will have resistance in that, because I think it's a great idea, and I think there's good technology and super applicable, but network engineers can be a little hesitant for change. So how are you seeing? Obviously, you've got your own internal team, but when presented to forums and groups of folks, are you getting that resistance from sort of something new or something different, or hey, you've been doing this for your career, this is what we're doing now, like this is a new standard, a new protocol, a new concept? Do you get any resistance from that sort of field and that industry?
We can almost cut the market in half. So there are providers that we talk to, and we walk in the door, they will be a well-known GPU provider in North America, and we say, we are thinking about these sorts of technology challenges, and they go, we want it immediately. How do we get involved? Here's some ideas from us as well. This is what we're thinking about. Then you go to the next provider, and they've got their CTO as an ex-telco chap, and you're in a conversation trying to explain to them what you're doing and why what they're doing is not going to work. And it depends who you're talking to and where, but there definitely there is a cohort of people, depending on how the organization's being built, where there is resistance. But then you have a more sensible conversation with them. You say, well, actually, what's going to happen when your next generation of GPUs comes out? Have you got the capital and finance to keep deploying and keep pace with that market? Because if you don't, you're going to have a very expensive 6 megawatt irrelevant asset. So actually making that asset available to a wider ecosystem that absolutely does want to consume it might be one of the only ways you can maintain commercial viability as a business. And to that extent, we've got lots of the funders in the GPU space now talking to us as well, because they're trying to build a wider business case inside their LP groups and their portfolios. And actually, if we're going to go and invest another 100 million in X company to go and buy GB200, how on earth do we justify keeping H100 spinning, or do we just strike off the balance sheet? And that's not going to work for most companies. So we have to get a bit more creative. And normally we can overcome those objectives, if you just try and take anything right now in this space and try and benchmark it against old, look at the cost of NVIDIA hardware, AMD hardware, chassis, racks, power, cooling. It's in an order of 50 times what the old world was. If you then look at the cost of interconnectivity through the same plane, you can't apply the same logic. It has to be that magnitude. Now, we're not 50 times more expensive than anybody else, but there is a scale cost to this when you're looking at doing what we're doing. So it does depend, and we do divide the market into those that are more technically led CSPs and those that are more commercially led.
Yeah. Now you talked about a GPU vendor in North America. Do you work much with alternate? Is there a view to where customers are looking to use Gaudi 2 or 3 from Intel, or some of the AMD chips and interconnects? Yeah.
Yeah, so we're right in the middle of that. So we're not just wedded to NVIDIA. We work with AMD, work with Intel and others as well. We've got a very keen eye on the emerging space. Had some really good conversations a couple of weeks ago with 2 more providers. I think there's a few things that are going to happen, right? And we're seeing this in some of the resourcing behind some of those vendors too. There is always going to be these large supercompute clusters being deployed with the latest hardware. But there is going to be this trickle-down deployment of, as NVIDIA is saying, anything less than a 10 megawatt site running H100s will become an inference edge location effectively. And then there are other chipsets being developed for things like cell sites and nearmast and 6G. And there's a diversification happening inside the GPU path, so allowing more industry-specific chipsets to emerge. And again, the only way that world works is by having it all connected together again. And they're not going to work over standard transport backhauls. So it is a strange space, and there is a huge amount of innovation. The other challenge is keeping pace with the market. And so we're fortunate enough to have lots of feedback and input from lots of other people, including some of the big storage guys. But for anybody else, this market's moving at breakneck speeds, and it's very difficult to keep the company at the very, very front of that unless you have that sort of exposure.
Yeah. What's really interesting, I find, is that thinking about the industry and the kind of maybe the media kind of discussions around it, there's obviously Elon out there doing hundreds of thousands of GPUs, and we talk about the tippity top, right? Those big training models and the big deployments and all the power needed and stuff. And then you kind of look at it I would say one of the tiers down, maybe it's 2 down, but the enterprise AI really hasn't started, right? And I think that's where the excitement is in my mind, because, the needs of the many or the most, let's say, are going to outweigh what we're seeing today. And so people talk about AI being a bubble and, this GPU hoarding of being, what are you going to do with all that infrastructure? And it's going to be, unused once we get to a certain, a point for large language models. But then you go, well, you've got everything that's not a large language model that we could utilize. You've got, Transformer 3.0 or whatever the next edition of, inferencing and transforming and getting all these sort of data together, whether it's text or video. There's just so much opportunity that it can kind of provide outside of, you just focus on one industry, right? So you look at, I'm really, really passionate about sustainability, but I think where AI has the best, inroad to create a lot of value and solve a lot of problems is in the health space. So accelerating diagnosis of all that type of, cancers and, early detection of whatever it happens to be. There's so many illnesses that are killing people all over the planet or impacting their lives. Early detection or advanced, processes to help solve for some of those things, can be done. Well, we can focus all this intelligence and compute on some of those problems. And my hope, I guess, is that we make some progress there, because it seems that's an area that really needs it. And that's just good for humanity. There's nothing bad that comes out of doing that. I think that's where, I really hope to see some real world progress and impact outside. Because I think today we've got videos and we've got, some accelerated learning, helpers and AI assistants and co-pilots, but really it needs to go in there.
Yeah, to your point there, right? So ChatGPT is just the tip of the iceberg. It's a way to make AI tangible to the regular man. That's all it is. And it's also not that smart.
It's a killer app, right? It was a killer app to get it out there. Yeah.
Yeah, it is. It pushes it into the market for enterprise adoption, for open market adoption. And to that point, like co-pilots, that's not that complicated really. Training model data on business data is not that complicated really. We sort of position this as it's actually the world recentering around GPUs. Look at applicationless applications that don't have a fixed home. Look at people like Oracle, SAP, now rebuilding their entire organization's enterprise IT stack to reside on GPUs as a compute asset class rather than a CPU entirely. And then you're absolutely right, the market signaling in robotics, logistics, healthcare, biomedical sciences, deep technology research. They're the natural use cases for that accelerated compute resource. We're working with quite a few of them. And when you have a sort of a relatively high level conversation with them, the major challenge facing them is how do we begin? How do we begin to get into this thing? I don't want to go to a particular GPU provider and go and buy some GPUs. That's kind of the end of the journey, really. How do I get my data from where it is into that? How do I get the format right? How do I begin to compile it? How do I get retraining abilities? It's more wide scale than just move data into GPUs, go train model. It's quite easy. That rolls off the tongue quite easily. Then we're talking to people like national retailers who are saying, I want to train a model based on footfall data around apples. And I want to inference that in real time. And I've got, presence in 17 countries. I want to remove regional bias. I need my data to be stored here. There's entirely new challenges emerging. And then we're working with brain mechanics companies who are using synthesis of brain waves to try and predict your dreams, all using accelerated compute. So we are just in the first few years of what's going to come behind and use this asset class next. And when we talk about, and it is totally. We talk about now, the next $1 trillion market is enterprise AI adoption. Enterprise includes all of that. We're yet to see the best.
Yeah. Yeah, I think we've yet to see much of, there's just so much that can be done. You talked about different industries there. Like, are you seeing any one industry or vertical that has more interest or sort of than what you expected when you sort of developing this product? Like, is it coming from all angles all the time? It's like a shotgun approach, or are you seeing, it's more from, you talk about the hyperscalers, or it's from, semiconductor companies, or it's from, previous networking, organizations. Are you seeing it there with like business to business type arrangements? Are you seeing any direct consumer that said, I want to use this in my, on-prem data center and, deployment? Where are you seeing the kind of the smattering of interest?
Yeah, so our business until now has been focused on working with the CSPs to bring them market-enabling functionality. But about 2 months ago, we started to now focus on our second stage, which is actually we are the natural bridge behind enterprise adoption of this, because we've got 62% of the European and North American markets connected to us currently. We're rapidly expanding in Southeast Asia. We're rapidly expanding in the Middle East. So we have got a very strong volume of people connected to us that this could be applicable for. As we're now polling that enterprise market, we're working very closely with lots of the vendors, and you can see the signaling in the team that they're recruiting now. Look at NVIDIA's London offices being in a life sciences research building, for example. There's quite a lot of reading into that you can do. We are definitely seeing net new inquiries to us from banking, financial services, and cybersecurity companies. We're also definitely seeing net new inquiries from life sciences, biomedical research. They seem to be the most prevalent currently, which you'd expect naturally. They're full of engineers and scientists that understand this technology. They've been trained on things like CUDA framework for the last 10 years. But then there's non-standard retail coming through as well. And then lots of tech startups doing things that are smarter than just co-pilots. We haven't really begun to see yet mass market enterprise adoption. I think it's probably quite daunting for organizations, and they can't quite understand the actual value of doing it yet, but it is coming.
Yeah. You talked about, the different geographies and things there. And so today the product kind of sits at a 100 to 200 kilometer kind of limit today. How have you got any, and we sort of talked about, some of the things being done in a sovereign way. So data centers and processing done, in country, for confidentiality reasons, for privacy reasons, for, GDPR, like for whatever it happens to be, compliance and regulation, whether today or tomorrow. Are any of those folks worried about some of those things over time? Discussions you're having where, you talked about the Middle East as well. And so, moving that data around can be not only challenging but costly, but equally it might actually be, I won't say in breach, but it might actually be in opposition to some of the requirements they might require from a regulatory requirement in their industry, medical, insurance, whatever happens to be. So does Stellia sort of play a role in that, or do you sort of help them kind of come to a solution? Like, how does that work with Stellia?
So our network already is almost global. We just can't offer all the products for GPU to GPU globally yet. The other products are available globally. So storage ingest, for example, is available. The sovereignty piece is a challenge for a few reasons. The first is, what do we mean by data? And that, it's a relatively unsexy thing to get into, but trying to actually classify what data actually means. Is it a dirty word? Does it mean consumer data? Does it mean information about you? Is it GPU to memory? Because that's also data. So when we say data must be sovereign, we're talking to lots of governments about this currently. We're at the conference last week about this as well, and we're talking to the Middle Eastern authorities about this too. When we talk about sovereignty, what do we mean? Do we mean consumer data must reside? Do we mean machine data must reside? Is it processed or pre-processed data? Because if you look at how some of the largest language models in the world are trained on, say, YouTube's videos, that's whole of market index trained. You have no reconciliation necessarily as to where that video was produced in the first place. It's very tricky as you actually get into the weeds of data. You have to start classifying it. And that's something that I don't think we actually have the legislative frameworks at all at the minute to actually try and do. We spent quite a lot of time with some of the Nordic governments and looking through their process towards trying to approach that challenge currently. And they definitely are understanding there's a reclassification of data needed in order to try and police this. We can hold data in certain locations. We work with some of the storage customers to go and do that. If people do, we are seeing more requirements from enterprise customers and new opportunities saying that I'd like to be within a region rather than a country. To that extent, the AI is definitely based around non-standard AI availability zones. So it's non-flat D markets. AI is where the power is, not where the data is, which is counter to the financial markets. So all this recentering is causing some turmoil. I think data sovereignty is very easy to get drawn into as well. I think it's a way more complicated subject area than most people actually understand, but it's a lot more than just keep your data inside one country. There's a lot more that goes into that with AI, especially when the models you are using fundamentally are most likely trained on data that did not originate or stored in that country. So you are using the outputs of open market data to achieve it. It's very, very complicated. And it's not clear how that legislation is going to fully come to light yet.
Yeah, and I think it's the challenge with implementing any type of regulation is just the let's say implied slowdown that it tends to do, and so where we're trying to go fast and we're trying to do more and do innovation, etc. It really can stifle some of those progressions, and and I'm just thinking I was thinking more on a well, not more, but I was thinking on a technical level, if there's a 100, 200 kilometer kind of gap, you might actually be breaching or going across into a different country within that 200 kilometer limit and be processing in, adjacent European countries. And, that might, you could, put some parameters around what you can and can't do. But I guess because of the complexity, that's got to be on the customer. Like you can't be, working out, well, if you do this and you do that, then, and worried about it. It's got to be, consumer choice to some degree, but you just give them the transparency and information and say, here's how we can do it. Here's what you need to know, good luck to some degree.
I don't think at the minute it's down to us to police that. And we have been postured by the British government. No, have you got the ability to police this? Well, in theory, yes, technically we could do, of course. But at the minute, there's not enough of a clear position morally or legally to be able to enforce policing like that. We already know of customers that are training data or moving data around within AI as they're contiguous data sets between regions. And I think that the only way that the modern world, the future world is going to evolve is going to become more borderless anyway. It has to be. I think the data position is going to get really, really challenging because the way this compute class works is not segmented and siloed in the same way that a big public cloud AZ would be in Frankfurt. It's not segmented like that. And to your point about distribution, disaggregation, we are seeing hundreds of 5, 10, 15, 20 megawatt deployments of AI all over the world. But that is all going to be reconnected as effectively one large supercomputer. And that's already starting to happen. And as newer and newer assets come into that pool, that cluster will become bigger and more distributed. It is down to the customer to create those end contracts and to decide where their data is. But natively, the way these systems work is way more distributed than typical cloud.
Yeah. That's a good segue because I was going to start to ask you about the future and you just laid it out in a nice little package for me, which is great. So I guess the extension of that would be, those 5, 10, 20, sub 50 megawatt, data centers and beyond are going to sort of interconnect to some degree. Stellia could be the big part of that story. How do you see things beyond, we got the GB200 coming out. I think, it had some setbacks and I think we're early next year or even late this, getting out there, the Blackwell chips and things. But beyond what NVIDIA is saying or what AMD is saying or what Intel is producing or even what the hyperscalers are producing as their own ASICs, do you see there being a world where quantum kind of comes in from the other side and so from a different point of view, but there's a I don't know, it eventually becomes something useful and becomes, more prevalent in the real world rather than kind of some of the science experiments it's been to date?
Yeah, science experiment is definitely the right way of phrasing it right now, I think. I think what
I'm probably offending people by saying that, but
anyway. But it's like, how else do you expect? Like, it's definitely way more mathematical and physical research right now than it is computational research in the quantum space. I mean, I think what the quantum movement is doing right now is creating the space for other innovation to happen around it, as opposed to being the innovation. And I'll probably get shot for saying that, but I'm seeing other.
we'll be shot together.
Right, fine. I'm seeing other industries and companies coming alongside that and using that as a starting point instead. So I'm undecided currently, and I can't give you an opinion well more formed than that, whether is quantum going to be the output or is it going to be the enabler behind the next technology revolution? I think everyone was skeptical about AI, and to your point about the AI bubble, I've had that conversation 1,000 times with people. It's not a bubble. It's a fundamental shift of asset class supporting the world that we live in. In terms of, well, look at it this way. How long has it taken us to get ChatGPT to become relatively thick but act clever? So if you ask ChatGPT a fully academic question that you are a subject matter expert on, it still cannot answer it. So to this point right now then, if it's taken this long to get that model to this point, how much more computational power and time is it going to take to get that model alone to be truly artificially all-seeing and intelligent? And that, you look at that, it's a huge divide still. It's massive, massive divide. If you can't Google it, it can't do it. So it's not actually fully intelligent. The future is somewhere on that track, especially within AI. And then you've got, artificial general reality and the general reality modal piece and augmented reality, then blurring the lines between what's AI generated and what's actually real. The future is somewhere over there. Quantum might be the next catalyst for innovation as the next compute class. But I think it's a bit too ethereal for most compute providers and consumers to understand. They're just trying to wrestle with AI yet before we even get to quantum computing.
Yeah. Yeah, no, I don't know enough about it to have an educated opinion either. I talked to a bunch of folks that are in that space, and actually Claudia Ogilvy was on this podcast talking about quantum. She's a sort of a, I would say, maybe a believer is the right word. She's an advocate for quantum and has a lot of knowledge in that space. But and I know what we talked about was it always seems to be just 5 years in the future. Like in 5 years, we're going to have this. And what I would say though is, and maybe we're getting biased by AI kind of showing us these magic tricks and things, that it does seem that 5 years isn't 10 years away as it used to be. It was like in 5 years, well, it's going to be more like 10, 15. 5 years sounds more believable than it ever did. And perhaps that's because we're sort of more open to for things being, to be surprised by goodness and for these things to sort of make breakthroughs. But I'd love to see it. I would, but you look at the infrastructure needed to cool those things, and you look at, the engineering needed and focus, and like just to have this little qubit stored and it doesn't fall to pieces. It's a pretty incredible engineering feat to even get to where we are today, physically and logically. Anyway, it's again, it sounds a bit science experimenty, but hopefully it bears fruit, because
I'm sure it will do.
have a huge impact.
I think it will transform our understanding potentially of how we think about data, certainly origination and movement. I know enough about it to understand how it works in a mechanical sense, but what I'm always trying to draw is where is the real world benefit to it outside that of just computational research? Because it has a clear benefit in the research space, of course. But as with AI, where will it actually benefit enterprise and humanity? To your point about healthcare there and advancements there, that computational asset class has got to deliver some sort of material output eventually. And the quantum class clearly has the horsepower to do something fairly transformational. But where that will be, I think it remains to be seen.
Totally. Well, it sounds like Stellia is well positioned to be part of the journey to get there by the sounds of things, interconnecting those large, islands of GPUs today to be, building those bridges between those islands to interconnect and kind of, stitch together. I think I referred to it as it's kind of the NVLink outside of the data center was kind of the analogy I used when we first discussed it. But like that's it. I'm super excited for the future of that. How can people get educated on Stellia? Is it through the website, your personal cell number? Like, how do people get involved and understand it more?
Yeah, so emailing the team at connect@stellia.io. Look online, find us on LinkedIn. We're at loads of events. So we're at events all the way through to the end of the year. I'm presenting at Apex Invest in November. The team are at Supercompute Atlanta. I'm out at Yotta. We are at all the events all the time as well. So stop any of us out there. We're a friendly bunch. We love to have a chat with people as well.
Awesome. Well, I'll see you at Yotta next week. Actually, we hopefully can get this produced before then, so you can, if the timing's right and the post production gets ticked off, I'll see you there next week. But I might see you at Supercompute. Do you OCP? Are you involved in the OCP community?
We are involved with the OCP community. Yes, we probably won't be at the event because it conflicts with another event we're at the same time. We're involved with OCP.
Okay.
We're founder members of the Ultra Ethernet Consortium as well. We're driving innovation at that point. We are advocating that neutrality position too. So we have to sort of, we say NVLink outside the DC, yes, but other technologies are available. Yeah.
Do you actually, just on that note, do you talk to the Sonic team at all, like with contributions to their kind of?
Yeah, so contributions to Sonic. We took Sonic, we pulled it apart, put that together again. We pulled in things like Orca and Monsoon a long time ago. We looked at Hedgehog and other elements of it too, but I mean, there's a lot of early learning in there that's really good. We need a little bit more than that. We need less of the stuff we don't need. Obviously, the problem with the production operating system is it is very much a jack of all trades and will do everything relatively well. There's also a lot of bloat in that too, and we need to approach this with stripping things out. Part of our early POC and one of the networks we currently run is running a reworked version of Sonic, and we're co-contributing to it.
Yeah. Well, it's funny. The theme for what we were doing at Amazon at the time was getting offloading from all these Cisco devices, which had thousands of features, which sounds great. But if you need three, you've got so many things that just a surface area of attack or problems or bugs or issues. When you're trying to connect thousands, and you got all these problems. I mean, the one problem I saw, I walked into a data center with one of these things in there we're replacing, and it had side exhaust. So you actually take up two rack footprints because these Cisco 7K devices were pushing out left and right.
Same with Cat 4K.
Yeah, this is stupid. And we had these these large perspex walls on, I guess, hot and cold aisle containment to some degree, kind of on the left and right of them, taking up all this space, using up all this thing, and it was just not what we needed at the time. And so replacing those with top to bottom, a bunch of routers that were Broadcom Tomahawk based and, a three-way CLOS network was a revelation. It was really what we needed. And that was the fundamentals of being able to deploy at scale for AWS and Amazon.com. So it's, when you only need a little bit, you don't need a lot, then you do it yourself.
And we looked at CPU resource allocation, memory resource allocation, memory locking. If you've got 1,000 protocols running, they're all somehow sitting in memory and sitting ready in the CPU. Attack vector is one point of it, but also it's more error for mistake. Frankly, from automation tooling, we'll eventually make a mistake. It's more things to think about. It's more bloat. And so you buy a laptop from an online retailer and it comes with a whole bunch of bloatware. Just don't want it. The first thing you do is reset it and put it back to factory again. When you approach this as a hyperscale design thought pattern, you look at what you need to achieve, not what features it's got. If you reverse engineer it, you do just build a product that has the features that you only need and not what you don't. Way more efficient, way less to think about.
Totally agree. Well, cool, man. I'll hopefully catch up with you next week. Thanks for thanks for being on the show and dealing with. I've got a bit of a cold, so thanks for working out muffled Australian. And mate, it's always good to talk to you. So let's keep in touch, and I'll hopefully see you next week.
Thank you very much, mate.